Vocabulary, an interactive visual tool for discovering intersectional biases encoded in word embeddings. And this work will be presented by Bhavya Ghai. So take it away.
Hello everyone, I am Bhavya Ghai from Stony Brook University, and today we'll talk about a project, WordBias. This is a joint work with my lab mate Naimul and my PhD advisor, Professor Klaus Buehler. So let's start with word embeddings in general. So word embeddings like word2vec can be understood as a mapping between a word and its corresponding vector representation. And these kinds of models capture the relationships between words that are based on some underlying data sets. Such word embedding models are trained over huge corpuses of text, let's say Twitter or Wikipedia or books, etc. And then they are used for multiple downstream applications, say sentiment analysis, machine translation, and many other applications. Word embeddings have the potential to directly impact multiple downstream applications. They can be used to bootstrap almost any NLP application. So if there is something wrong going on with the word embeddings, it can seriously impact multiple downstream applications. Recent studies have shown that word embeddings can learn and exhibit biases based on race, based on gender, ethnicity, etc., which were encoded in the training data set. Biases in word embeddings are manifested as stereotypes or undesirable associations between words. For example, it has been found that males are disproportionately linked with career and maths, while females are linked with family and arts. Existing literature primarily focuses on individual bias types, let's say based on gender or race or age. However, in the real world, an individual might face compound discrimination due to their affiliation with multiple social categorizations based on gender, race, religion, etc. For example, a Black Muslim lady might face discrimination because of her race, religion, and gender all at the same time. Quantifying a complex sociological concept like intersectionality is a difficult task. Word bias considers a word to be associated with an intersectional group, say Christian males, if it strongly associates with each of its constituting subgroups, that is Christians and males. This is a narrower definition of intersectionality, but quantifying it exactly is a matter of further research. The point is that we need to focus on biases against intersectional groups and not just against, commonly known bias types. For the first step towards tackling a bias is to identify. So in this work, our focus is to identify bias against different intersectional groups. So how do we quantify bias? In our work, we have used a metric called relative norm difference. So let's imagine the word embedding space, which has a subspace which consists of female-oriented words. Let's say words like she, her, herself, mother, etc. And then there can be other subspace which has words which are male-oriented. Let's say he, him, himself, etc. Now, what we do is we just take the average of these words to get a representative vector for that group. So here the vectors G1 represent females and G2 represent males. Now, for any word in this word embedding space, you simply calculate the distance between that word and G1 and G2. For example, in this case, we see that there's a word nurse, which has a smaller distance to G1 than compared to G2. This shows that the word nurse has an inclination towards females than compared to males as per this word embedding. Ideally, the word should be equidistant from both of these vectors. And in our particular work, we will compute such bias scores for multiple kinds of biases, and then we will show them in a visual interface. So there are 4 design goals we're looking after in our particular work. First is word association. So given a word, let's say priest, our tool should help identify the different subgroups that the word priest is linked to. For example, it can be males, Christianity, old age, whatever. Similarly, given a subgroup, or let's say males or females or Black Muslim females, any group, our tool should help identify the different words that are strongly associated with each of these groups as per the word embedding. Next, as we just saw previously, that we do not want to just cater to some well-known biases. Our tool should also help work with underreported biases, let's say based on physical appearance or political leanings, or even any other user-defined bias type. And lastly, as we know that word embeddings have thousands or even millions of unique tokens, so we should have our tool which can withstand large volumes of text, both at the front end and at the back end. Now let's take a look at the tool itself, its different functionalities. How does it work? I'll give you a brief demonstration of that using a video. This is the visual interface of WordBias. Here each axis represents a particular sensitive attribute like gender, religion, race, age, etc. And either side of each axis encodes a particular subgroup. For example, the gender axis has female subgroup at the top and male subgroup at the bottom. Similarly, we have Islam here at the top and Christianity at the bottom. And each of these blue lines here represents a particular word. We can simply hover over any word to see how it associates with different subgroups. For example, here the word nuns has strong association with female, Christianity, white race, old age, and poor economic subgroups. If a word is not present on the word axis, we can simply go over here on the search box and we can search for a word that we want to see. So let's say we search for the word corrupt and we can simply click on the word and then the word appears on the word axis. Here you can see that the word corrupt has a strong male, black, and poor subgroup orientation. Now let's say we want to visualize the different sets of words. So what we can do is we can go over here on this histogram and we can select different words by brushing over the x-axis here. We can even go on and we can select all the words that are there in this tool. And now let's say we want to figure out which words are associated with the intersectional group black, young, poor. We can simply go over their respective ends and brush over these subgroups. The words that you're seeing here, struggle, hunger, uprising, all of these words strongly associate with each of these different categories, and hence these words are linked with the intersectional group poor, young, black. Now we can pick and choose different subgroups to see how different words associate with different subgroups. So let's say for the intersectional group white, old, rich, we see words like attractive, formal, desirable, castle, deserts, golfing, etc. Apart from the default set of axes, our tool provides the flexibility to add any new user-defined bias type. We can come over here and let's say we try to define a new axis titled weight and it has two subgroups, let's say thin and heavy. And then we write down a set of words which define each of these subgroups. We click on add axes. Here we go. We have this new axis, right, as we intended. Okay, so I hope this demonstration gives you some idea of how the tool actually works. I will recommend you to read the paper for much more details on how this actually works. There are a lot of things that I cannot share in this limited time frame, but that's I think a good start. So what we did was we tried playing with this tool over multiple intersectional subgroups, and we on the word-to-vec word embedding model trained over Google News dataset. And some of the striking associations that we found are listed in this table. So we can find that here, let's say the intersectional group Black Muslim males have words like gun, assassination, bullets, bribes, all these kinds of words linked to it. So we can imagine that many of these associations, or maybe all of these associations, might be considered as socially undesirable. If left unchecked, these kinds of associations or biases will directly propagate into downstream applications and cause further havoc. So it is important to first audit a word embedding and fix its biases before using it for any downstream application. So for use cases, we believe our tool can be used as an auditing tool by researchers or data scientists to audit a word embedding model before deploying it for any downstream application. It can be used as an educational tool to teach about how bias comes in word embedding models in a classroom setting. And as we know that algorithmic fairness is an interdisciplinary domain, so many people don't have that coding background, so they cannot access the right code and do all of those things. So this kind of visual interactive tool can boost accessibility for different domain experts to come in and participate in this kind of a setting. So in conclusion, word embeddings can be laden with different kinds of social biases. It is important to audit a word embedding before using it. We present a tool which can help you do exactly that, that is figure out the different kinds of biases in a word embedding. We showed our findings based on word-to-vec embedding trained on Google News dataset. And for the future, we look forward to support contextualized word embeddings such as BERT or embeddings trained over different languages, say Hindi, German, other languages, and also include much more sophisticated fairness metrics that can better capture the multipolar world. And I will highly recommend you guys to go in and check this GitHub page where you can access the paper, the code, and also the live demo. You can play with the live demo right now if you want to by going on this link. With that, I thank you all for your attention, and I look forward to your questions.
So yeah, with that, I guess we have a question about from Nicole. Have you thought about how this tool might be misused?
Yeah, I think this tool, so there are many things that are going behind, computing the bias score. So we need to first know which words can you consider representative of a particular group, let's say males or females, whatever, right? If you choose only a few sets of words, or if those words are not actually quite representative of that particular group, then whatever bias scores you will get, they might not be representative of actual reality, and hence you might come up with false claims which might be wrong. In our particular paper, what we did was we just tried to use the words which were already used in multiple previous papers. Although having said that, there is not yet a very objective way to figure out which set of words can accurately represent a particular group, whether be it Asian Americans or females or whatever they might be. They're all going and trying to figure these things out, still a active research area. But that is one thing that I can see might be a possible thing where you just use this tool with different sets of words, and then you come up with false claims about the word embedding itself.
Great. And then we have one more anonymous a question from an anonymous attendee. I didn't even know you could do that in Zoom. I like that. Can you load your own word embedding models into the application?
Yeah, so at this point in time, unfortunately, we cannot do that because we need to, it's a lot of computation to first compute the bias scores. Our objective was to give the user a real-time experience. So if we have, let's say, a word embedding, which is like maybe thousands of megabytes, for example, uploading that into a remote server and then doing the computations, and then it might take some time. It is certainly possible, but we look forward to supporting that feature as well. But at this point in time, it is not there. Sorry.